All right. Okay, so I like that we already talked about SOH 101 because here is literally just a reminder of the equations. We've talked about how these are ratios and how that 0.9 or 0.5 gives us an idea of which is longer, the opposite or the hypotenuse, right? Let's do the following. Solve the following right triangle. Now, let's remember, what does it mean when you are asked to solve a triangle? What does it mean? What is it asking for? All the missing information, right? So it means find all sides and angles. And you're expected to know this. So I will give you a question with a triangle and say, solve the triangle. And you are expected to understand that you need to find all the missing pieces. And you're asked to do it using only the trig ratios. So no Pythagorean theorem, okay? Round to one decimal place. All right. So as I start, I'm going to first label my triangle. I am given an angle of 18.6. I'm going to make that my angle of interest. And I'm going to label the triangle based on that angle. Opposite, hypotenuse, adjacent. Yes?
So we can't define the angle of C by just
We will. Yes, we will do that for C. Let's circle what we have. So we have the hypotenuse, what we want. Let's start by finding the length of side A. So if I'm starting off by finding side A, which trig ratio am I using? OH, I'm using sine. So I have that sine of 18.6 degrees is opposite over hypotenuse. I multiply both sides by 11.3. Okay, once again, you're punching everything into your calculator at once. Like, I want to encourage you not to press sine 18.6 equals times equals. Yeah. So do you have, yeah. I wonder if you have to go 18.6. Yeah. Yeah. So what you have to do is enter the angle first. Okay. So you can go 11.3 times. Well, that's true for everyone. That's just a different way of measuring angles. It should always be in degrees. So 11.3 times, what is it? 18.6 sine. And then equals, right? This is the 18.6 sine. Well, try that out now, Leo. All right, so what did we get? 3.6 centimeters. Is it approximate or exact? Excellent. All right, moving on. Let's find side C. Now, here's the question. Now that I have the length of this side, it's 3.6. Should I use the hypotenuse or the opposite? And there is a better answer. Why? Exactly. It is more exact. So if I'm using 3.6, I'm already using a number that is not exact. So that means my answer will be even less exact, right? It's going to be approximate to start with, but now it's going to be double approximate. So if possible, use the information that is given from the start because that is more accurate. Does that make sense? So in this case, I'm using A and H, and that's cosine. So I'll write cosine 18.6 equals side C over 11.3. I rearrange by multiplying 11.3 cos 18.6 degrees. What do we get? 10.7 centimeters, approximate or exact? Beautiful. Okay, lastly, we must find angle C. And folks, we're going to do that using the sum of angle theorem. What is the sum of angle theorem? I'm going to write that word. I know, but for this, I'm just going to maybe cheat. Sum of angle theorem. What does it state? All angles in a triangle add up to 180. Okay? So if you need to put that on your summary sheet, then you're doing that. Right? All angles equals 180. So as a result, angle C is equal to 180 subtract the other two angles. Well, there's a 90 degrees and there's an 18.6 degrees. And essentially, I'm going 90 minus 18.6, which is 71.4, is it? Approximate or exact? Very nice. We didn't do any rounding. Very nice. Reminder that angles are represented by uppercase letters, capitals. Sides are represented by lowercase letters, and they're always corresponding. So angle A is across from side A. Angle B is across from side B. Does that make sense? Remember that? Let's look at the next question. So in this case, we are not given any angles, so we must solve for an angle right away. Now, you might be like, oh, can I solve for the hypotenuse using Pythagorean theorem? And the answer is no, right? Let's use trigonometric ratios. Now, once again, I just want to, yes? No, it's not okay to use Pythagorean. All right, once again, how to label a triangle. Angle D is across from side D. You don't have to circle these. I'm just saying. Angle E is across from side E. These are called corresponding angles and sides. Now, let's use our CTB and let's make predictions. Side E. What can you tell me with 100% certainty about how long side E is going to be? It is 100% going to be. So give me a number. Greater than. I can say it's going to be greater than 7.4, right? With 100% certainty. And the good thing about doing this is, let's say you use your calculator incorrectly and you get something like 2.5. You're like, oh, but I made a prediction. I must have made a mistake somewhere. Okay, this is a bit harder. Which angle out of D, E, and F is going to be the biggest angle? Definitely E. Okay. Which one is going to be the smallest? Is this like, do you know why? Yes. Because the corresponding side of F is the shortest. So F and F are corresponding. And so if side F is the shortest, that also tells you that angle F will be the smallest. And if side D is in the middle, that means that angle D will be in the middle. This is another really good concept to understand in order to check your answers when you say, does my answer make sense? Okay, so let's start by solving for f just cuz. So if angle F is my angle of interest, that would mean that side F is opposite, side D is adjacent. So to find angle F, which one am I using? TOA, that's tan, opposite over adjacent. And some of you might be like, can I just skip to showing you that I know I'm doing the inverse? Sure. And then all of this, again, punching it in our calculator. So you need to use brackets. Right? Get really good at using brackets on your calculator. So Liam, for you, you're going to be doing bracket 6.5 divided by 7 for bracket, and then shift tan. And I get 41.3. Others? How can we find angle D easily? We could do some of angles. We will do some of angles. So angle D is 180. Subtract 90. Subtract 41.3. Try to do this in your head. Basically, you're doing 90 minus 41.3. So first think, okay, what if I round up 41 to 42? What's 90 minus 42? Okay, it's going to be 48. But then there's an extra 0.7. So yeah, it's 48.7. Let me check if I'm right. Add 0.7, that gets me to 42. Add 8, that gets me to 50. Add 40, gets me to 90. Cool. Exact or approximate? Beautiful. Lastly, we need to find side E. I'll use F as my angle of interest just because I already have it. So I'll use hypotenuse and I'll use opposite. I'll do so. You could use ka, right? So I'll say sine of 41.3 is going to equal to 6.5 over E. Yeah. You got it? Excellent. And then I'm like, oh yeah, I remember Miss Sly told me that if the variable is in the denominator of a fraction, I can swap these, right? So the E takes the spot of sine, and sine swaps with E. Again, let's practice using our calculator all in one go. If you're nervous about that, use multiple brackets. We're looking for an answer that is 9.8. E is approximately 9.8 meters. Are we calculating it okay? Do we need any help with the calculator? Liam, did you get it? Okay. When you're done your calculations, what should you do? Check, does it make sense? So go back to our predictions. We said side E would be greater than 7.4. Is it? Yes! Pat on the back, Miss Sly. Then we said angle B is biggest, then D, then F. Is that true? 90, 48, 41. Yes! Double high five for myself. All right, we good? Let's step it up. Okay, time for some exercise. Get up on your feet. Everyone, up, up, up. Stand up. We're doing the good old mummy walk. Up, up, up. Stand up, everyone. Kinesthetic learning just for you. All right, pretend you're doing the mummy walk. Do. Action. So put your hands out like this. Make one of them stuck. One of them cannot move. Okay. And they have to be parallel to the ground. Yes. Now, use one of your arms to make an angle of elevation. Nice. It goes up. Where is the angle of elevation? Is it above my arm or is it between my arms? Yes. So remember this silly picture. Miss Sly's head is between my arms. It's touching the horizontal. Now go back to the horizontal. Make an angle of depression. Where is the angle? Is it under Miss Sly's arms or between her arms? I'm going to put my head there. Silly picture. Okay, the angle of depression touches the horizontal and is between the two arms. Great. Okay. So the mistake that is often made is that the angle of elevation, like when you label the angles, it's not touching the horizontal. The angle must touch the horizontal. George looks out from the CN Tower observation deck and sees his house at an angle of depression of 10.5 degrees. A sign below tells him he is 447 meters above ground. How far from home is the CN Tower? So in this diagram, it is labeled that the distance we're talking about is the horizontal distance between the CN Tower and his house, not the diagonal. Where is George? Draw a dot as to show where George is. Yes, he's up here in the small bubble at the observation deck. We're told that he is 447 meters above ground. And when we measure height, it's always a vertical line that is perpendicular to the ground. Oh, that's a right angle triangle. Next, we are told that from where he stands, the angle of depression is 10.5 degrees. Now, George spent some time in Miss Sly's class, and he remembers that when you do the angle of elevation, you put your arms out, you drop one arm, and that the angle of elevation is where her head is. So I want you to label that on this diagram. Okay, make a mistake, but try. Where is the angle of depression? Sorry, I said elevation, but I meant depression. Maybe you need to add something to the diagram, like perhaps the horizontal, right? You have to, from where George stands, there is a horizontal. Now that we have the horizontal, where is 10.5 degrees? Well, it's touching the horizontal, right? That is the angle of depression because it has to touch the horizontal. You want to so desperately just put it right in the triangle, but I am sorry, that is not how it goes. Yep.
Can we just put it between the ground and the diagonal line?
Not yet, because that is not representing his angle of depression. So now we go back to grade 9, one of Miss Sly's favorite lessons in geometry, where you have two parallel lines, and I forget the name of that line that goes through, and then you get to use highlighters and draw a Z. And do you remember what we learned here? The parallel line theorem for Z is that the two angles on the inside of the Z are what? Equal. As such, yes, we can say that this angle here is also 10.5, right? As a result of the parallel line theorems, right? We call it parallel line theorem dash Z. Do you remember which other letters are part of the parallel line theorem? C and F. Good job. Great. All right. So now I will redraw my triangle just to make it clear what I'm working with. This is 10.5. This is what I'm solving for, and this is 447. Do I have enough information to solve? I've got one side, one angle, and another angle. I need 3 pieces of information to do anything with a triangle. I have it. Yeah, so I'm good. Okay, so if 10.5 is my angle of interest, this is opposite, this is adjacent. Let's solve for x. I'm using tan, opposite over adjacent. What do I do with the x and the tan? Swap-a-ruchi. I don't know, man. This looks like an unrealistic number. Does that make sense? Does it make sense? What is this number? Like, how would you say this number? How far is George from his home? 2 kilometers, right? 2.4 kilometers, right? Oh, it's 2,000 meters. Oh, so it's 2.4 kilometers, right? It's approximately 2.4 kilometers. Does that make sense? Yeah, it makes sense. Let's go back to the whole idea of corresponding sides. Which angle is the smallest angle? 10.5. Does it correspond with the shortest side? Yeah, it does. Great. I did a check in my head. It makes sense. All right. As if that wasn't enough. Of course, that wasn't enough. Let's bring in trigonometry into geography, right? I always talk about physics. Come on, Miss Lai, that's not fair, right? We did a bit of social sciences, but let's talk about geography. Yes, so we can use trigonometry in geography, okay? And what we're going to use trigonometry in today is to find the diameter of the 49th parallel. What is the 49th parallel? Okay, we're talking about longitudes. Do you remember longitudes and latitudes? And longitudes are the ones that lie flat. And the 49th longitude is up here in Canada. It's like literally a circle around the earth, but its circumference is smaller than the circumference at the equator, right? Because they get smaller as you go up and down from the equator. Now, the way that we determine that it's the 49th parallel is we literally measure the angle of elevation from the equator. It's kind of cool. So this is the equator. And then the 49th parallel or the 49th longitude is 49 degrees up from the horizontal, and you draw a line until it hits the edge of Earth. What does this distance represent in a circle? It's going from the center of the circle to the edge. It's the radius. Well, guess what? We are told that the radius of Earth is 6,380. Now I want to pause because I want us to understand what it is we're finding. We're asked to find the length of this. Is that the circumference or the diameter? Before you answer. So this is a two-dimensional picture. This is like me cutting Earth in half and just drawing a line here. This picture here is a three-dimensional picture where you can see the full circle. That green line is connecting one edge to the other edge. Is it the circumference all around or is it the diameter? It's the diameter. In this case, you're being asked to find the length of the diameter at the 49th parallel. Now, do you see a triangle in here? Yes, but it doesn't include the entire diameter. It actually includes the radius at that point. So watch this. I'm going to make this my triangle. Do you see how it's a 90-degree angle? I'm going to redraw it so that I'm just focusing on my triangle. I know the length of the hypotenuse. It's 6,380 degrees. Oh, sorry, 8 kilometers, not degrees. 49, where do I put it? Does it go in the lower angle or the upper angle? Oh, based on what? PLTZ? Oh, you guys are such nerds. I love it. I'm so proud of you. Yes, based on PLTZ, where we go bum, 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 this angle and this angle are identical, right? So here we have 49 degrees. Great. So I have one piece of information, two pieces of information, three pieces of information. That's all I need. I can solve, right? I'm never using the 90 degrees in my equations, but that's the 90 degrees was incorporated in the derivation, in the creation of these equations. What do I want to solve for? I want to solve for this. Okay, I'm going to call that my x. So if 49 is the angle I have, am I using cosine or sine? Good. This is my hypotenuse. This is my adjacent. So I'm going cosine of 49 degrees equals x over 6. Go ahead and solve for x. Hi. Liam, are you figuring out your calculator? Pardon? Okay. Yeah, it's just going to take some habit making of putting the angle in first. Do not delete this number from your calculator, blah, 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 blah. Do people know how to use the answer button on their calculator? Yeah. So let's say I deleted my answer. I'm like, oh no, I forgot to keep that number in here. I'm going to write 2 times answer. Ooh. And why did I do 2 times whatever I got? Because that's the entire length. Okay? So length of 49th parallel is, can I just write the answer or do I have to say approximately? I do. It's so annoying, but I do. Is approximately 8,371 kilometers. It didn't tell us how to round, so I just matched it to the information given. Right? I wasn't given any decimals. Do you get that? Folks, I am pretty sure, this is like a 90% promise, that this kind of question will show up either on the quiz or the test. Okay? 90% sure of it. Lastly, let's use the primary trig ratios to solve for an angle which has two triangles overlapping. Right? We need to solve for theta. Well, what I'll do first is I'm going to label my triangle or triangles. This is angle A. This is angle B. This here is angle C or vertex C. And this is vertex D. Vertex is where two lines meet. Plural of vertex, anyone know? Vertices. I wish. All right. So in which triangle should I start? Where do I have more information? ABC or ABD? And why didn't I even say ADC as an option? Not a right triangle. And I'm using primary trig ratios. So I'm going to start in triangle ABC. I want to find this angle. How can you name that angle so that I know which triangle you're in? We're going to call it angle CAB or BAC. What it tells me is, oh, it's the angle that goes from vertex B to vertex A to vertex C. It's important that I do it this way because if I just said angle A, I wouldn't know which triangle I'm talking about. Yes.
To find the angle, like solve for theta, can we just do the adjacent side of 10 and the bottom side of 18?
That just gives you the large angle. The other way you can communicate it is to say, hey, in this triangle. So whichever one you do, let's solve. So I'm going to say tan of CAB equals to 12 over 10, right? Opposite over adjacent. I'll reduce my fraction. Why not? Being fancy, Miss Sly? Yeah, kind of.
Instead of writing tan CAB, can you write tan theta?
Nope, because it's not. Okay, I get 50.2 degrees. Next, we move on to the big triangle ABD. So now I'm solving for dab or bad. If you're not sure how I'm getting these letters, please make sure that's something you approach me at extra help with. Once again, it's tangent. And I know that because I have no information for hypotenuse. So tangent of angle dab is going to be, now I need to add the two sides, right? That's going to be 18. It's going to be 18 over 10. And again, as I write tan inverse, I want to reduce my fraction. 9 over 5. You don't have to, but it maybe smaller numbers are simpler. I don't know. Tan 9 divided by 5. I get a bigger angle. That makes me relieved, right? I should be getting a bigger angle. 60.9 degrees. Am I done? Let's think, what is the question asking me for? Oh, I have to solve for theta. So I am not done. Theta equals subtract the two angles. This is a definite do it in your head calculation. Is it approximate or exact, folks? Because I was using approximate values. Folks, with the last 5 minutes, do you want me to show you how to solve the last question on the test? No? Okay. The one we just had.
Yeah.
Yeah? Okay, let me stop the